Hello everyone, welcome back. My name is Mr. Cobalt, and in this video we're going to go over another problem involving dimensional analysis. Okay, so in this problem we're given some percent by mass, and we're given density. So we're going to learn how to use those as conversion factors. So in this problem, it says a water solution that is a 15.0% sucrose by mass. So that's going to be important. So 15% sucrose by mass. And it has a density of 1.059 grams per milliliter. What mass of sucrose in grams is contained in 3.05 liters of this solution? So when we're always attacking a word problem like this, the first thing I always tell my students is to pull out the conversion factors, pull out those relationships, because those relationships that they give us are going to be used as conversion factors. So that's the first thing. So let's read through the problem. Let's go through this. They give us 15.0% sucrose. Whenever you're given a percentage, you're going to use that as a conversion factor. So you got to rewrite that as a conversion factor. So you got to understand what a percentage means. Percent is per 100. Remember, think of century. A century is 100 years. So cent is 100. So percent is per 100 out of 100. So that means that whatever your percentage is, that's out of 100 of whatever your unit is. And so since this is percent by mass, we're going to use a mass unit. And since they want it in grams, why not just use grams? So let's write this down. So that means that if we have a water solution that is 15% sucrose by mass, that means that if we have 100 grams of our sucrose solution, I'm going to just write this as sucrose solution, then that means that out of this 100 grams, 15% of it is sucrose. So that means out of 100, we have 15 grams of sucrose. So for 100 grams of sucrose solution, we have 15 grams of sucrose in that solution. That's what the percentage means. So now we have our equality between grams of solution and grams of sucrose. We can use that as a conversion factor. The next one is density. So density, anytime they give you a relationship, you have this unit per unit. So something per something, grams per milliliter, meters per second, and so on. Anytime they give you something per something like this, think conversion factor. That's going to be used as a conversion factor. So here we have density, grams per milliliter. We have, we have 1.059 grams per milliliter. So we're going to write that as an equality. So if we have 1.059 grams of this solution, that means that's going to equal 1 milliliter of that solution. So that's what the density is telling you. 1.059 grams of mass of that solution is going to be the same as 1 milliliter of volume of that solution. So we have this equality, and we can use that as a conversion factor. Now, that's all of the relationships they gave us. So what is left? We need to figure out where we're going to begin and where we're going to end. And I always tell my students that it's always in the question. So 99% of the time, the beginning and ending of your problem is in the question. So, and also the beginning of the question is the end of the problem. Again, the beginning of the question is where you're going to end. So what's the beginning of the question here? What mass of sucrose in grams? That's what they want in the problem. That's where we're going to end. That's our goal. So I have my arrow. My ending is what mass of grams of sucrose in grams. So what grams of sucrose? I want what grams of sucrose. Okay, so now where am I going to begin? Well, look at the rest of the question. It says what mass of sucrose in grams is contained in 3.05 liters. So 3.50 liters is where we're going to begin. So liters of solution. So they want us to begin with 3.05 liters of the sucrose solution, and we want to get 2 grams of sucrose. So we know where we're going to begin, where we're going to end, and the rest in between is multiplying by your conversion factors to get to your problem, to get to the solution of your problem. All right, so we begin with the beginning. That makes sense. So we have 3.05 liters of solution. And I always put it over 1 because I am going to be multiplying by fractions. I'm going to be multiplying by ratios, which are my conversion factors. So I set this up as a ratio or as a fraction. And there's no unit here. I'm just putting it over 1 to create the fraction. And then I'm going to multiply by conversion factors. So I have liters of solution. I need to get rid of solution. I want to go to some other unit. So here I have grams to grams. Here I have grams to milliliters. And let me write this in. This is grams of solution, and this is milliliters of solution. We need to be very specific about what we are converting to and from. So, and this is a good time to remind everyone that whenever you have a conversion factor, you should have, especially in chemistry, you should have the number, the unit, and the substance you're talking about. So here's my 1.059 grams. The grams is my unit. Solution is the substance that I'm talking about. And this would be, if I wanted to be more clear, it'd be sucrose solution. So sucrose solution. Okay. Now, so I want to be able to use milliliters, but I have liters. So my first step is to convert to milliliters. Once I convert to milliliters, I can now use this relationship as a conversion factor to convert between milliliters and grams. So I'm going to write my line there to write my ratio, my fraction. And since I have liters of solution here, I want liters of the solution on the bottom to cancel out. So now to go from liters to milliliters, I need to write a conversion factor that was not given to me. It's a metric to metric conversion factor. And so this relies on my knowledge of the prefixes, the prefix multipliers. So if you haven't memorized those, you need to memorize them. So what is that other conversion factor? So the way I set this up so that I don't make a mistake is I'll have one unit compared to another. So here I want liters and milliliters. So I'm going to set up an equality and I'm going to put milliliters on one side and not meters. I'm going to put liters on the other. So liters compared to milliliters. And now what I need to do is fill in the blanks with numbers. I always put a 1 with the unit that has the prefix. So I put a 1 here with milliliters. And then I put the prefix multiplier with the base unit. So I need to know what milli is. And milli is 1/1000th of whatever the unit is. So here it's liters. So that means it's 10 to the negative 3. So I'm going to put 10 to the negative 3. So 1 milliliter is equal to 10 to the negative 3 liters. This is a true statement. So this is my conversion factor that I'm going to use. So I have liters of solution on the top here. So I'm going to put liters of solution on the bottom. So my 10 to the negative 3 liters goes on the bottom. So 10 to the negative 3 liters of solution goes on the bottom. And so my 1 milliliter goes on top. So 1 milliliter of solution on the top. My liters of solution cancel out. Now I have milliliters of solution. Excellent. So guess what? I can now use this relationship here. Milliliters of sucrose solution, 1 milliliter is equal to this many grams of sucrose solution. So I'm going to set up my next conversion factor. So I have milliliters of solution on the top here. So I want milliliters of solution on the bottom to cancel out. So I'm going to put 1 milliliter of sucrose solution. So 1 milliliter of the solution on the bottom. And I'm going to put the grams of sucrose solution on the top. So 1.059 grams of solution. So milliliters of solution cancels out. Now I have grams of solution. Excellent. So, but that's not where I'm going to end, right? Because I need grams of sucrose. Just be very careful with this. So I want grams of sucrose, not grams of sucrose solution. That's why it's really important to put exactly in detail what you are looking for, what your units are about. So I need to go from grams of solution to grams of sucrose. So now I can use my percentage as a conversion factor. So solution will go on the bottom. So I'm going to need my next conversion factor. So I have grams of solution on the top. So I need grams of solution on the bottom. So 100 grams of sucrose solution goes on the bottom. So I have my 100 grams of sucrose solution goes on the bottom. And that means that 15 grams of sucrose goes on top. So 15 grams of sucrose. So now grams of sucrose solution cancel out here. And now I have grams of sucrose on the top. So once I have the unit I have on the top, now look here, grams of sucrose is what I want. That's my ending, that's my goal. Now I have it on the top. Once you have the unit that you are looking for on the top, you're done. You don't have to do any more conversion factors. So this is it. So we've set up our problem. Now all we need to do is calculate it. So let's go ahead and calculate it. So I'm going to take my calculator. Okay, and all I'm going to do is multiply by everything on the top, divide by everything on the bottom. If it's a 1, I skip it because it's not going to do anything. So I take 3.05, so 3.05 multiplied by 1, multiplied by 1.059, and then multiplied by 15. Now I'm done with the top. Now I'm going to divide by what's on the bottom. So I'm going to divide by 10 to the negative 3. So 10 to the negative 3. Okay, and I'm going to divide by 100 equals. And I get, for my answer, I'm going to put this in blue. So I get 484. So 484 0.4925 for 4925, and it's grams of sucrose. So grams of sucrose. Okay, I've got my answer. So that's half of the problem. The other half is I need to figure out the number of sig figs that this answer belongs in. I can't write all of this in. I'm only allowed a certain number of significant figures. Well, how do you figure that out? Remember the rule for sig figs when you're multiplying and dividing. We multiplied and divided here. So the rule is your answer should have the same number of sig figs as the least number of sig figs that you used. Okay, so let's look at the sig figs here. We have 3.05. This has 3 sig figs. 3 because that 0 is significant because it's between two non-zero numbers. This here is an exact relationship, so it has an infinite number of sig figs. We can ignore that. Here we have 1.059. This is a measure. So notice that we have a volume unit being compared to a mass unit. That is not an equality. That is a measurement. So here we have 4 sig figs. Again, the 0 is between two non-zero numbers, so that 0 is significant. And here we have a percentage, and I didn't write the full percentage like I should have. So this is actually supposed to be 15.0. And so 15.0 grams, that is 3 sig figs. And remember, the 0 at the end of a number is significant if there is a decimal point. And look, we have a decimal point. So therefore, that 0 is significant. So therefore, we have 3 significant figures there. So we have 3, 4, and 3. So the least number is 3. So that means we're only allowed to keep 3 sig figs. So we can keep the 4, the 8, the 4, and then everything else cross off. So notice you have a 4 here. So you don't have to round this number here. So remember, if the number following your last digit that you can take is 5 or greater, then you got to raise this up by 1 digit. But here it's a 4. So our final answer is 484 grams of sucrose. So that is your answer. So I hope this was helpful. If you like this video, please like the button here. Share the video with your friends and others, and put a comment in the comment section. Let me know what you think. If you have any other questions, don't forget to subscribe to this channel. If you like my videos and you want to keep getting new ones, please subscribe. Thank you for joining me. Have a great day.